Okay, for part B of this question, we would like to show that on the curve C, which is of course defined parametrically like so, x equals 2 tan t plus 1, y equals 2 sec squared t plus 3, we'd like to show that on this curve, y equals a half brackets x minus 1 squared plus 5. And the best way to do this is just directly. So we can take this right hand side, we can work out what this gives us, and hopefully it will agree with y. Let's try it then. So if we take, first of all, we've got 1/2, and we should make it really clear that we're working with the right hand side. We've got 1/2 brackets x is 2 tan t plus 1. So 2 tan t plus 1. But we need to do x minus 1. So we've got a minus 1 here, and we're squaring this, and then we add 5. So luckily for us, that plus 1 and minus 1 are going to cancel out really nicely. Let's see what happens. So we've got 1/2. And inside our brackets, because the plus 1 and the minus 1 disappear, these two go away, we just have 2 tan t squared. And that's going to give us 4 tan squared t. So 1/2 times 4 tan squared t. And we've still got our plus 5 on the end. That hasn't gone anywhere. So what we've got now is 2 tan squared t. 2 tan squared t plus 5. Well, we'd like to show that that's equal to our y that we have here. And to do that, we need to change our tan squared into a sec squared. This is one that I always struggle to remember the identity for, but luckily we can just derive it ourselves. So if we start from one that we definitely know, which is cos squared x plus sine squared x equals 1. And then we need to divide through by something. We should divide everything through by cos squared x. So when we divide cos squared by cos squared x, we're just left with 1. When we divide sine squared x by cos squared x, we get tan squared x. And when we divide 1 by cos squared x, we're left with sec squared x. Well, this is the identity that we want to use, isn't it? We would like to use tan squared x is sec squared x minus 1, or sec squared t in this case. Let's actually do that then. So instead of 2 tan squared t, we've got 2 lots of sec squared t minus 1. Sec squared t minus 1 plus 5 on the end. That hasn't gone anywhere. And now you can see we're pretty much there. We've got 2 sec squared t (2 times minus 1 would give us minus 2, and then plus 5 would give us plus 3 overall. And 2 sec squared t plus 3 is exactly what we had earlier for y. So we've shown at this point that's equal to y, which was our left-hand side. We've shown that these things are equal to each other. And we're done on part B.